Hello everyone, in this demo we learn how to draw wire to make it thinner. You should have a piece of round sterling silver wire of a length of about 2 to 3 meters and the diameter should be 2 millimeters. We'll cut a section of about 15 to 20 centimeters, and for this you can just use your pliers to cut it. And this piece of wire will be put aside and we'll use it to make the clasp after we make the chain later. So what is left is going to be used to make the chain, but it needs to be of a smaller diameter. The requirements for the project is 1.4 millimeters. This wire will need to be annealed to soften it and to make it more malleable and more ductile, so that we can draw it and make it of a thinner diameter. This is how you should prepare your wire for this. You're going to make a tight bundle. And this will be safer for yourself, but also for the wire. You won't risk melting it when you anneal. It's important to tuck each end so that the bundle doesn't come undone and stays tightly together. So there, you're ready to anneal this bundle of wire. For this demo, I'm using a small butane torch, a type of torch that you might be using at home. It is small and portable, not quite as powerful as the torches we have at school, but very easy to use. Lean your wire against a brick, a charcoal block, or your third hands. It's much faster and much safer for the wire to anneal the wire when it's not flat on the brick. It helps to have a little bit of air in between. For safety, hold your wire with your fire tweezers. And I'm speeding up the video at this point, but you have to do this very slowly, methodically, and consistently. And it helps to do one short section of wire at a time and keep the flame on it until you see the color change in the metal and in the flame, which indicate that the metal is annealed. So be consistent to make sure the whole length of the wire is evenly annealed. Let's resume our normal speed at this point. We are almost done. You see how the wire has expanded and shifted as we warmed it up to anneal it. After annealing, you will air cool the wire and pickle, rinse it and dry it. And that's it. You'll be ready for the next step. You notice that annealed wire feels different and also looks different from wire that is not annealed. Annealed silver or annealed wire is softer. It's no longer shiny, but it has a matte finish or a milky white color. And this is because during the annealing and pickling process, the fine silver comes up to the surface of the metal. We have one more thing to do before we can draw this wire. Don't be afraid to modify your bench pin to make it easier to work. In this case, using an old file, not your wood file, we'll file a tapered groove into the pin. And that will make it easier to file a nice even taper. The taper doesn't need to be perfect, but it needs to be long enough, about 3 to 4 centimeters is fine. And this allows us to hold on to the end of the wire and to pull it through the draw plate with the draw tongs. Use a hand file, cut 1 or 2, whatever you prefer. Cut 1 would be a little faster. And that's how you would file the taper. I will speed up the video at this point. And we're almost done. Just keep turning the wire to create this tapered shape. And we'll resume normal speed, and we'll be ready to draw the wires through a draw plate to make it thinner. Draw plates are used to change the shape of a piece of wire, to make it round, square, half round, and so on, or they are used to change the size of the wire. That's what we're going to do here. We are going to place the draw plate into a vise. I have put copper sleeves on the jaws of the vise to protect whatever tool or piece of equipment I put in between. Here is the draw plate. It has a series of holes of different sizes. This one is for round wires, so the holes are round, and this is the front and the back. The numbers are the sizes in millimeter. The draw tongs are used to pull the wires through. And we use wax to lubricate the wire. You could also use a chunk of beeswax. And a safety reminder, don't forget to use eye protection. We are going to feed the wire into the draw plate from the back of the draw plate. Since our wire is 2 millimeters in diameter, we are going to feed it into the 2.00, the 2 millimeter hole first, which should go through very easily. You should never force the wire into a hole that's too small. This process needs to be done in small increments. You place the draw plate into the vise. The numbered side is facing you. You feed the tapered end of the wire through the 2 millimeter hole, and it should stick out on the front of the plate. Apply some wax on the wire at the back of the draw plate, and with the tongs, you grab the end of the wire and pull steadily and evenly without jerking the wire, which would damage it. I'm not showing all the process here to shorten the video, but you would repeat with the next smaller hole and then the next smaller one. Usually you can go through 2 or 3 different size holes before you need to anneal the wire again, as it becomes work hardened at that point. So this is where we pick up in the demo. My wire at this point is 1.5 millimeter. I've checked with the calipers. I've refined a nice taper. And this is what the reading says on the calipers, 1.5. So I have one more hole to go in the draw plate to get to the 1.4 millimeter diameter. Here's 1.5 and 1.4 millimeters. We'll put the draw plate into the vise again with the numbers facing the front, and we'll repeat the process. Tapered end, first from the back. It should stick out a little bit. Apply wax just behind the draw plate on a short section of the wire, and with the tongs draw the wire through. It goes in easily because it is the 1.5 millimeter hole. Steady lay and evenly. I like to double check again, and it should say 1.5 still. Now we'll repeat the process. We feed the wire the next smaller hole, which is 1.4, and apply wax at the back of the draw plate, and we'll pull through with the tongs, and this is 1.4 at this point. So pull evenly, steadily, and then we'll double check the measurement again with the calipers. And it should read 1.4 millimeters, which is the required diameter for our project. That's it. Thanks for watching. Bye.